Good evening. Thank you guys for joining us tonight for our second webinar for AP Statistics. My name is Amy Chow, and I will be moderating tonight, helping with answering questions. We also have Dr. Karen Greenhouse helping moderate as well. And then Ish will be our presenter. For those of you that have not been on a webinar with us before, we will keep everyone muted, as well as all videos turned off. If you do have a question, pull up your chat panel and type the question in there, and Karen or I will do our best to answer the question. If it's something that we see that's kind of popping up a lot, we'll stop Ish when we get a chance and ask him to answer the question to the entire group, depending on the questions that we get. So it would be a good chance now, if you haven't done it yet, but to pull up that chat panel and have that there ready to go in case you have any questions. So just to give you guys a little bit about myself, Ish, if you'll go to the next slide. Thank you very much. I am the training and product manager with Casio Education. I've been working as an educator for the last 14 years. My primary duties with Casio right now are just all these trainings, webinars, conference workshops, curriculum, and helping out with marketing as needed. Karen, would you like to introduce yourself?
Yeah, I'm Karen Greenhouse. I am a professor at Drexel University, and I also work with Casio, and I do a lot of like right now, I'm very immersed in creating ClassPad lessons and doing videos for the calculators and stuff to support teachers who are remote teaching at the moment. So that's sort of my role, is just supporting teachers and Amy.
Thanks. And we appreciate all your help. And Ish, on to you.
Hello. Yes, I am Ish Zamora. I am math department chair at York High School. I am also here to keep Amy happy and also to keep Karen happy. So I've been teaching for over 20 years, taught everything 7th, 8th grade through AP Calc, AP Stats, which I taught it like 13 years. I haven't taught it, I think it's been a year and a half since the last time I taught it. Tutor lots of kids with it. Been doing a lot of work with AP Stats for a really long time. The way I tell people is, if you want to teach a math course that you talk about the things you did on day one, on the very last day of school, and it's not because you're reviewing, AP Stats is the way to go. With all the information that we're inundated with on a daily basis, AP Stats is such a great place to get fresh topics, new conversation. Kids rarely ask, when are we ever going to use this? Because they're seeing it used every single day. If you're following models and what's going on with the global pandemic, that's another place where you see statistics being used by people all over the place. So you see the uses of it, you see the power of it, you see how you can interpret information. You can have the same set of data, and it can be interpreted lots of different ways by lots of different people. And what's really great about it is, the more I see about statistics and the more I see about what we're trying to get students to do, it's about understanding information and trying to make sense of their world. And stats is one of the best ways I've seen that kids actually ask questions and then answer their own questions. And it comes down to, can you support what you're saying? Are the statistics in your favor? Are they not? How can you interpret them? How can you use them? We've got the AP Stats exam coming up tomorrow at 1 o'clock. So this is one of those last second, how can I use something like my handheld calculators to be more effective on something like the AP Stats exam. So we'll be using the 2016 exam, particularly question number 6. I love question number 6 because it touches on every aspect of AP Stats in one question. And if you've followed AP Stats for a while, the question number 6 tends to be the longer question. It is the question that is the open response, where you really have to dig in and construct a whole lot with it. It's the one question where you should be spending most of your time. It has high percentage of the points, lots of interpretation, lots of places where you can shine, just show what you've got. The other reason I really like this question is because it's an example of Simpson's paradox. And we talk about Simpson's paradox and all the kids giggle. Great thing with the Simpsons being on for 30 some years and still on the air, that they get a chuckle out of it, and you have to remind them it's not Homer Simpson, it's somebody else. It's a different Simpson. The great thing about statistics is most of it is brand new. Relatively speaking, geometry has been around since the Greeks and Pythagoras and all these, going way back, the Chinese, ancient Mayans, you name it, the culture, they had geometry, they played with geometry. Statistics came about relatively recently. I mean, we've been looking at data, but a lot of the statistical models that we use today, some of them were created in the late 40s, 20s, 30s, 40s, and they continue to grow. So some of the things you see with box and whiskers plots, for example, when you talk to kids, they assume that stats is a really old ancient science, and you go, you know what, no, John Tukey came up with this relatively recently, and he just passed not too long ago. So it's a nice thing to be able to tell kids you're basically at the infant stage of statistics, and statistics is probably one of the most powerful mathematics that's out there that can be used. So again, I just love it. I can talk stats all day long, but we only have an hour.
Yeah.
And I got to introduce the software. Yeah, so yeah, Amy mentioned early on, if you've got a question, feel free, type it in there, raise your hand. She will try to interrupt me. As you can tell, I like to yammer, so I will yammer on topic now. So question 6 from 2016 talks about salaries and numbers of semesters of hours out of college. So it appears that the more semester hours you attain from college after you leave, your salary in euros will tend to go upward. So it looks like we have an upward trend looking at this data set. The way I use this question in particular with my students is I give them the data set. I've taken and stripped away all of the nice graphs, and I ask them to answer this question as if they had nothing but the data set. So I want them to create their response from nothing. So you hand them the data set, you can share data sets, and ask them to input it. If you've never used the 9750G2 or any of the Casio handheld graphing calculators, they all work very similar. The icons are maybe in different places depending on which model you've got. This is the 9750G2. This is the base model. If you're looking for a calculator that does it all, this does it all and then some.
And there's a new version coming out.
Oh, I saw that.
Yeah, the 9750G3.
I saw it at Walmart. I almost bought it. I should have. That thing looks so cool. I won't even get into my calculator collection. I've got over 100.
Oh my gosh.
You gotta, when you geek out, you gotta geek out full on. I mean, I've got their prototypes and calculators that never saw the light of day. Again, that's a different show for a different audience at a different time, but man, I'm so proud of that. Anyway, I still got to add to that collection with the G3. That thing looks so darn cool. So the icons might be in different places. What you may notice is, the way I tell students to operate this calculator the first time is, assume you're using your cell phone. Kids use their cell phones for everything. This works more like a cell phone than a calculator. So most people are very used to calculators being, oh, there's a screen, I got to start typing something in it. These are very specific with icons. This icon-driven menu on a handheld is something Casio started a long time ago, way before cell phones were even thought of, or even personal data devices, the Blackberries and things like that. So this has been out there. I think the only company that may have had anything like this was Xerox, and Xerox had it in the 70s, but they didn't do anything with it except hand it over to Apple when they came around. So this is a platform that's been around for a while. So what is it I want to do? Well, I want to do stats. It is an AP stats course after all. So I'm going to be living in icon number 2 here. I got a couple of ways to do that. I could use my wheel, move it up, down, left, or right, or I could just type the number 2, and number 2 would jump me right into the stats menu. Look at that, by the magic of the internet, I have entered all of the data into list 1, list 2, and the other lists, which I will talk about when we get to those part of the question. So there's 24 data points.
Hey Ish, real quick, can you see if you can kind of fix your mic a little bit? It's getting a little staticky.
Oh,
Yeah.
any better or worse? I can try a different
About the
headset.
same.
It's about the same.
Yeah, that's the same.
Let me try a different headset. Hold on.
Okay.
Sorry, folks.
That's the life of using technology, isn't it?
Yeah, no. All right. Any better?
That's much better.
Much better.
Yeah.
Oh,
Thank you, Ish.
Yeah, sure. I got a couple of them, along with over 100 calculators.
All right.
All right.
I got a couple different headsets. Let's see, I got the internal mic on. Let's try the Logitech headset. How's that?
Sounds good. Much, much better. Yeah.
Yes.
All right.
Thank you.
That's what happens when you try to cross platforms using 2 different platforms for one system. All right, so here we are.
Yes.
So here's my data set. All 24 values, all plugged in, ready to go. I was able to open this in a PDF that allows me to see what the actual points are, but it wasn't that hard.
How did you get the data?
Yeah, that was actually, I downloaded the PDF, and when I click on it, this is on my PDF reader, and I just hover over it, there is some text boxes that pop up. So you see that yellow text box? Mm-hmm. That actually came up. I think that is because AP is accessible. So if you can't read the screen and you have a screen reader, you could actually hover over it and the screen reader will read those data points. So that's where I got them from. You could read these just by kind of eyeballing it and figuring out what they were. And if I'm working with students, it's a good idea to try to get something as close as you can. Just realize that your answers may be slightly different if you eyeball it and it really wasn't exactly the same. But if they're constructing this for the first time ever, they would have their data set ready to go. If it's an AP question where they are required to put in the data, it has happened from time to time, they will be given the data set and they can plug that right in.
All right, I was wondering about that. Thank you.
Sure. So looking at this, I would want students to say, okay, based on my data, I can't really tell just by looking at the information. I've got to do something with it. So what I want them to do is when they open up this icon that has stats, they will see all the tools along the bottom of their calculator screen. And what you've got to do is just keep an eye on those tabs. And those are operated by the function keys F1 through F6. So I press F6, which has a little arrow, just to show you what else is there. So those are some tools for editing your data sets, your list. And I come back, I can graph, I can calculate, do a test, an interval, or some distributions. All things which I will be doing a lot of in AP Stats. But you shouldn't do anything with stats until you can see what the graph looks like. So you see the little graph tab, which is underneath or above the F1. So I press F1. I tell my students, don't do anything. The calculator will assume things. You want to operate the calculator. You don't want the calculator operating you. So you always want to set it up. So I will press F6. And it says, I'm going to do a stat graph that is a scatter plot. It's coming out of list 3 and list 4. Well, I don't have list 3 and list 4. I have list 1 and list 2. So I just want to change that to say list. And it says list 1. And then I will toggle down, choose list and list number 2. And then if I have a frequency list, so if I had a frequency, for example, the number 1 shows up 15 times, you could also have a frequency list. So you could either choose the frequency is 1 because everything in list number 2 represents itself and nothing else. If I had a frequency list, let's say everything in list 2 was represented by a frequency, which would be in list 3 or 4 or whatever, you could change that there, but we won't. Mark, you got a couple different marks. I'm going to just choose the default F1, which is the little open square. That lets me see when the line goes through it. You can talk about all sorts of really nice things. So I will exit that out because it's all set up. And now watch what happens when I press graph 1, F1. There's my list, my scatter plot. There was no need to set the window. The window is automatically set by the calculator. It does so by default, but that can all be altered or changed if you want your students to set windows. And that's a conversation that, depending on the level of a student, depending on the time of year, depending on the subject, you may want them to set up a window. So if you go Shift Menu, you could decide that your stat window should not be set up automatically, but it should be set up manually. What the automatic window does is it looks at your extremes, your minimums and maximums, and then makes a decision to make sure that you could see the max and the min and nice even intervals. So it looks at both X and Y, and it fits a nice window to it. If you want to save residuals, which if we're looking at scatter plots, if we're looking at residual plots, you would want to set up a residual list, in which case I could put list number, and I've got 1 through 26 to choose from. So you could save your residuals somewhere. We won't do that today, not yet, because this is an AP test and we've got only an hour. What else could I do? I can put this in different files, subnames, you name it, you can set it up. You could even put a background picture in there, but that's a conversation for a different webinar. All sorts of great stuff. I'll go back. There it is. Now I'm looking at it. I don't want to leave this area. I want to always be thinking about, what is this telling me? It looks just like the picture I got. When I assign this, I don't give them anything but the data set and the question. So they're looking at it and saying, well, there looks to be some kind of a linear relationship here. I want to calculate. Notice my options of what I want to do are right on the screen. There's no need for me to look for them somewhere else. So I'm going to calculate, and all my choices now change. I've got more options and more options and more options. The logistic one is at the very end, which is a great one if you're ever looking at epidemiology or the spread of disease. Logistic curves are awesome. We don't do enough with those in math classes, at least not at the secondary high school level. So what I want to do is I want to do a linear regression. So that's an X regression, and I've got a choice, AX plus B or A plus BX. Being the AP stats people we are, we're going to lean towards A plus BX. Algebra 1, algebra 2, they'll probably go AX plus B. Science is an A plus BX. So to stay with the theme of AP stats, I will choose F2. It calculated everything. Notice there's no need for me to worry about, am I going to get the R and the R squared value? Yeah, I'll get those. I'll also get the mean squared error. And it tells you everything about it. It's a linear regression that's in the form of AX, A plus BX, where A is 34.4. And this is in thousands of euros. So if you're assuming no hours out of college, your intercept would be 34,000. So you'd be expecting about $34,000 a year for salary for somebody who has no experience, no college above their degree, their bachelor's degree. The slope, 1.122, which if you come back to the question, it's a little different than the one that they used. Now, that's the question some of my students had for me was, why is one output different than the other? Outputs will vary depending on the software package. So some calculators, some computers, especially computer programs, do a slightly different calculation when they do least square regression equations. This one's just called a linear regression, so we'd have no idea if it's a least squares regression. It looks like it could be, but we have no idea how they're defining things. So it will be slightly different from software package to software package. It's not a big deal. That and country to country. Some countries, we found out in a different conversation just this week that there are some countries that calculate things statistically slightly differently based on weights and the frequency of certain outcomes. But what can I do with it? Well, I could copy it or draw it. I always tell my students, you went through the trouble of calculating it, copy it. It's going to copy it. Notice I go right into graph 1. I want to put it right there, and it'll overwrite whatever's currently there. So if I wanted to, I could have copied this into Y2 or Y3 or Y4. It really doesn't matter where, but I copied it there. And now I draw it. Now, keep in mind, I have not gone out of my graphing stat window. I stayed here the entire time. I've never lost this. All of my options changed based on my choices. So it's like anything you do with apps, phone apps, your choices will change depending on where you're at. So depending on where my choices had taken me, I graphed, I decided to calculate. I could have decided any one of those. I decided to go with linear, do another F2. I copied it, executed it, and drew it. So again, reinforcing the what's going on here. Well, it looks like it's a weak, moderately strong, linear relationship between semester hours and salary. So I would expect my students to talk about that, to copy this graph on a Word document, or if they're doing this on a Google Doc, they could also do that. Which, since I'm here, let me just show you how I would have my student take a picture of this. On the software, there's a little camera here. I just click the camera. You notice I got this little sticky that comes up. This little sticky thing right here is another one of the windows that I've got that has that scatter plot. So those I could just go, you know what, I want to copy that and I want to paste that into a Word document. They can paste it there and then type up their answers. So always want to make it as simple as possible. I want them to be able to express themselves. I want to be able to see what they saw without having to recreate the wheel or have to draw this by hand. So it's a nice, easy way to keep everything moving. So let me just exit. Now exit is just like a backup. So I'm just going to back up, right back to my data set. So question number 1 that they had was, does the scatter plot support the newspaper's report? Yeah, it does. I mean, it is a linear relationship. It's not the greatest linear relationship, but it is linear. It's got about a 0.56 as far as the strength of it goes. So they explain what it means. What does the slope mean? The slope on ours was 1.12. So for every semester hour that you go up, your salary will increase by 1.12 euros, or thousands of euros in that case. So we want them to be able to express themselves mathematically. This table that the calculator or the computer gave them, we got the same thing. So this time, instead of having to go through and do that whole thing, let's take a look at something else. How about it? What if we calculated the regression for X? And this time I'm not going to copy it on the graph. This time I just want to know, you know what was all that information? I just need that again. There it is. Again, I still have the option to copy this because the calculator realizes you went through the trouble of calculating it, go through the trouble of putting it into your grapher, and make sure that you can see it on a scatter plot eventually. So this table, I would also ask them to take a picture of and turn that in when they did their assignment to duplicate this same information on the bottom. The information on the bottom also has things like t-values and p-values. Well, just because you're not paying a whole heck of a lot of money does not mean you're not going to get great functionality. So if I was going to ask them if a linear model was the best model for this data set, I would expect them to do some kind of a test. So what I'm doing there is I'm going back till I see all of my options. I want to choose test. It's a t-test, and I could have a 1 sample, 2 sample, or a t-test for regression. So I'm going to do a regression t-test. Notice I don't need to know any of the syntax. All I have to do is fill in the blanks. Does this look like it's a greater than or a less than? In this case, it does not look like it's a linear model. So I'm going to say it's not equal to. So in this case, we're looking at both beta and alpha. So we're going to go down, list 1, list 2, which again we could change, frequency list if we had one. You can save your results from the test. I've put them in list 15. You could also have none. So if you wanted to save the results, if you wanted your students to show you the screen that has all the results listed in there, you can actually put them in a list. And I chose list 15 just because I know I'm going to use the other lists like 1 through 9. I couldn't remember if I had one for 10 and 11. I knew I didn't have one for 15, so I went with 15. So then finally, all you got to do is go down to the bottom where it says execute, and you've only got one choice, calculate. Again, notice I don't need to know any syntax. I don't need to leave the stat screen. I'm in one spot. I'm doing it all from one button at a time. So I hit calculate. It tells me the results of the t-test. So a t-value of 3.23, a p-value of 3.7 times 10 to the negative third, which is like 0.003. Depending on your alpha level, you're probably going to reject the null hypothesis. Your degrees of freedom, your A and your B, your standard error, your R squared. Again, you want to copy that. You could copy it. It's going to put it right into your grapher again. And then when you exit, you've got all of that, and I did it in a couple of button pushes. So it was not too difficult to get a lot of great results there. On to the next one. Well, what if I wanted to do a confidence interval? Well, let's see. Next option over is an interval. I could do a Z or a T. I'm going to do a T interval. You could do a 2 sample or a 1 sample. So you could do intervals. Something that I've never seen in a handheld calculator, maybe one other one, but I don't think I've seen it. I haven't seen this happen in too many like stats packages out there. If you go into distributions, you got your regular, normal, T, chi, F, binomial, Poisson, geometric, and hypergeometric. Pretty impressive. I still can pronounce my Poisson with only 1 year of French. So, Miss Marcancini, thank you very much. So let's see, what was I going? Oh, you've got the normal, inverse norm, normal P, normal C. You got T. You got chi, inverse chi square. I have not seen that in many places. F, inverse F. Binomial, inverse binomial. Poisson, inverse. I think you're starting to see the pattern. Inverse geometric, inverse hypergeometric. Something I have not seen in very many calculators. The distribution key, the inverse geometric, is a really awesome way to look at different distributions differently. That's a little bit of a harder calculation to do by hand, but having a handheld that could actually handle it is incredible. So let's go back to our question here. Identify the slope of the least square regression line, interpret the slope in context. So I think we've done that. So now here comes the twist. The twist is the data was actually talking about 3 different majors. So an independent researcher, again, a great reason to have statistics is you want to be able to replicate all of your results. So an independent researcher looked at this data and broke it out by majors, looking at business majors, physics majors, and chemistry majors. And this is where Simpson's paradox comes into play. If you look at a data set and you break it up into different subgroups, it actually changes the result. So where this was a positive linear relationship, if you look at the individual majors, now you're looking at a negative relationship. So it looks like the more semester hours I have under my belt for each one of these majors, you're actually going to be getting less money. So let's take a look at the data. Again, if I'm doing this with students, and in the times I gave them the data set, which again, I don't know if this is just my PDF reader or what, but when I clicked on it and held on one of the little points on the screen, it actually gave me the whole thing. And again, that's because of accessibility. So hopefully you can do that with all the AP questions. I think you can if you download them directly from the site. So the data sets are all plugged in my calculator. I've got one for business majors, X and Y, physics majors, and chemistry majors. So let's just look at one at a time, and then we'll do all three of them. So we'll just do business majors. Again, I want a graph. I want to set up my graph. I want to do a scatter plot. This time my data sets are list 3 and 4. Toggle down and list 4. There we have them. All the other stuff, I don't have a frequency, so I can exit. I will just go ahead and graph that first one. So again, that mirrors my worksheet that I have. Just looking at the business majors, I could calculate the regression like I did before. Define graph means if you could look at it and you could actually define your own graph. So if you wanted to say, I believe X is this and Y is that, or my slope is one value. So if you're trying to do it by yourself, you can. Because my window has been changed a little bit, I don't know exactly what those increments are, so I won't do that. What I want to do is I want to create this exact same graph with the different markings, and then I want to be able to calculate all the different regressions one at a time without leaving the graph, without having to change the entire thing and worry about which one am I on? Am I looking at this one? Is it included or not? So let's just set up graph number 2. So graph number 2, I've already set up to be lists 5 and 6. Let's change the marking. They have a little plus sign. We'll go ahead and use the closed dot. I will exit that. I will set up. Now I want to set up graph number 3, so F3. And that one's going to be out of 7 and 8. I've done this ahead of time, so that's why the 7 and 8 auto-populated. Otherwise, you'd have to actually change those yourself, which we've seen us do, and I'll turn that one into an X. So now I've got 3 graphs that I want to show. So I want to select all 3 graphs. Again, the vocabulary we use on the graphing screen here mirrors what we want to say in class. We never want to have to teach technology. I got into teaching math because I wanted the opportunity to teach students how to do mathematics in a way and enjoy it. And it wasn't very enjoyable when you have to teach them all the syntax and commas and what has to go here and what has to go there. If I say I want to see those 3, I want you to select those 3 and show them to me. So graph 1, graph 2, and graph 3, all of them have been selected. They're all on. So when I press draw, there they are, mirroring pretty much what I've got in the screen on the left here. So now let's calculate. I'm going to calculate a regression, AX plus B, and you notice now I have choices. Calculator says you got data set graph 1, or if I toggle up, there's graph 3 or graph 2. Which one do you want? You can also go downward. So I was on 1, so let's do 1 first. So I'll select 1. There it is. It is a negative slope, much stronger linear relationship. It's an R of 0.866, R squared, explainable error, unexplained error, 0.75, mean squared error, pretty small. Copy that one into, I'll just overwrite that F1 or Y1. I'll draw that one. I'll go back. I want to do another linear regression. I want to do A plus BX. This time I'm going to do the second set, which is my physics majors. I want to go ahead and calculate that one. There it is again, another negative relationship, fairly linear, better than the original data set. Mean squared error, all the good stuff. Copy that. I want to copy that in list number 2, so Y2. I want to draw that again. I want to do it one more time. I'm still on the screen. You notice I don't have to leave the screen and redefine what it is that I wanted to do. I still want to do a linear regression model on a different data set that I'm currently looking at. So I want to execute that. Again, I want students to interpret this information. Linear relationship, it is negative, -2, negative r, r squared, mean squared error. Again, I want to copy that information going into list number 3, and I want to draw it. I could even go out, and let's say I wanted to change the line. I could change the way the line looked even. So if I wanted to, I could go in there and change I want to change the style of the line there. I want to make it a thick line for line 1. Line number 2, I want to make it a thick dotted line. And line number 3, I want to make it a thin dotted line. Exit and then draw those. I get exactly what I want. So again, the technology needs to help me express what I'm trying to say. So if I'm trying to demonstrate that these 3 data sets are different because majors in business have a negative relationship, physics majors, negative relationship with more semester hours, chemistry major, negative relationship with more semester hours, and I want to distinguish between all of them, I can do it very easily. Then I'm never leaving this environment. I'm staying in the graph the whole time. And my calculator is saying, in this graph area, these are the things you can currently do. So again, no need to leave each one of the environments. So what was I able to do? Well, if I wanted to look just at the business majors would have been list 1, list 2, would have selected that one and just talked about, I'm going to talk about this thick line. So when my students create their information, their little, take their picture here, which the picture doesn't have to be that small. What I've found is you can always blow the picture up to be bigger. You can go up to 10x. The 10x is awesome. It is huge. If you're doing a PowerPoint slide, it is an enormous one. You don't lose a lot of resolution. The problem is if you put it in a Word document, it scrunches everything down and you have trouble finding that little crosshatch to make the picture smaller. Here I am doing hand signals and then realize that I'm on a webinar with no video camera. So pretend that I'm holding my hand up in the air and trying to find the little crosshatch and make it smaller. All right, so what else could I do? Oh, median. So we want to talk about medians. All right, so let's go out. And we'll go out again. We'll exit and exit. So let's calculate. I had choices. I was usually calculating regression. Let's say you just want to know the median salary for the 3 majors. So I want median salary for all 3. Medians for the salaries are going to be my Y values, so business Y, physics Y, and chem Y. And if you're wondering how I did that, I'm using my keyboard. So on the emulator, I'm able to use my keyboard. So I could have gone business, capital Y, and changed the name of it. So it'll actually let you change those names using your keyboard. If you don't have the keyboard, if you had the calculator, you'd have to use the alpha keys. So you could do it that way as well. So I'm going to do a one variable, but again, I want to make sure I set it up. My one variable stats is coming out of list number, let's see, 1, 2, 3, that would be list number 4 for business majors with a frequency of 1. If I'm looking at 2 variable stats, it would have been coming out of list number 7 and 8 with the frequencies of 1. Again, I stress with my students, never let the calculator assume what you're trying to do. Always tell it what you want it to do. Always set it up. So when I do one variable statistics, I got my X bar. I got my mean X squared, standard deviation for the population, standard deviation for the sample, the difference of n versus n minus 1. N is 8. 5-number summary coming. Min, Q1, median, Q3 max. The arrow keeps pointing down. Mode. I've got a mode that's 32, 35, 37, 38, 39. Keep going. There's 8 modes. Each one has a frequency of 1. So again, great piece of statistics software here in a really easy to use format. Mode is something that we assume students can figure out relatively quickly, and they can, but it's also nice for them to be able to punch it into their machine. And if I say it, they will believe me. About 40% of the kids will believe me. If their calculator says it, 99% of the kids will believe it. So again, the calculator should support what I'm trying to do. So what's the median salary? So let's go back and answer that question. Median salary is 38.5 thousand euros. So we'd write that down or take a screenshot, and then they'd be able to tell me where they got that from. Could you modify the description? Oh yeah, so if you were to change it, you could change it. So you could change your decision and say, you know what, based on the new data, it looks like the more experience you have in each one of these majors for semester hours, the less you are likely to get paid. But let's do something else. Let's do, let's go back out. We'll do some more calculation. If we wanted to do two variable statistics, now remember this is coming out of list 7 and 8. Here's X list. Scroll down, there's your Y list. The sum of the product of X and Y, standard deviations for both, means and maxes and mins for each one. But what other kind of graphs can we make? Well, let's make a different graph. We just talked about 5-number summary, so I'm going to set that up. Just to show you how easy this is to do, I'm looking at graph number 1. Graph type, scatter plot, X and Y. Normal probability plot, which is the same thing as your normal quantile plot, which looks at z-scores. You can make a pie graph. Again, that's one that you take for granted that many calculators don't do pie graphs. Histogram, box, bar graph, end distribution, broken. Here's your regressions. You got more, you got more, you got more. So let's go with a box and whiskers plot. So I'm making that a modified or a median box plot. Again, I don't know if I turned on my outliers. Oh no, my outliers are currently turned off, so I want to turn those on, just in case there is one. Again, you have the control of how you want to do this. So we're looking at list number 4. If I wanted to see that same information as a graph, so let me make sure I've selected only the first one so that I don't have a myriad or a couple of different graphs going on. I've only got one. So here's my graph. You could trace and trace across the values. Now notice what you're being given here. It's a stat graph. It looks like this. I'm currently here. There's the value. As I toggle over, it changes, it changes. It shows you all the information. If there would have been outliers, it would have shown those. But let me exit once, graph that again. If you wanted to see the same information, again, I don't want to leave the environment to be able to say, what is the 5-number summary? Where is all those great statistics, all that data that was given? If I do one variable statistics without leaving this graph, I'll do one var stats. Here's my one variable statistics with all the same thing that I'd calculated earlier, but this time in a nice table where I could look at everything, including the modes, and then I can go right back to the drawing. And if you wanted to, you could set this up for the other values. So if I wanted to, I could go with list number 6. And then I'll do it one more time with list number 8. So I want to set up stat graph number 3. I want to make this a box and whiskers plot. Median box plot. This is coming out of list number 8. My outliers are turned on. Exit. I think my graph 2 may have been set up differently. Graph number 1, yeah, that's where I messed up. Let's make that graph 2. We want to make that box and whiskers plot coming out of list 6. Outliers turned on. And let's just make sure that graph number 1 is set up correctly. That's list number 4. So if you wanted to compare all 3, set it up, select, so that we've got all 3 of those selected. Go ahead and press draw. And now you can say even more about the information. Which one of the majors is making the most money? You could trace the different graphs. That's graph 1. There's graph 2. So business majors were first, physics majors were next, chemistry majors were last. So then you have a nice conversation on your hand about which major and where the middle 50% is for each one, and how it looks like the chemistry majors out of all of them have a higher median than even 75% of the physics and 100% of the business majors. So if you've got students who are making their decisions strictly based on salary and how much money they're expected to make, you can have that conversation. Again, I talk to them as all of us talk to them. Find something you're going to be happy doing for the rest of your days, because you never know. If you're not happy, you're not going to like doing it probably for very long, regardless of how much money you make. So those are some of the features. Let me see, what else do I want? Let me pause. Are there any questions before I continue yammering?
Not that I can see. Remember, if you have a question, to write it in the chat panel.
Yes. All right. So let's see. What else can, oh, something I did not show. Since we're showing off the software here, I've got something here called a key log that I did not show yet. So let's say I wanted to, I'm teaching this topic or teaching this virtually from home, but I want to show a video of the key presses that I'd used to create the scatter plot. The great thing about teaching with video is kids could rewind it and watch it as often as they want. If you check out the YouTube channel for Casio Education, tons of great videos out there doing that exact same thing, just walking you through. But let's say I wanted to do it for my class and I wanted to show them the button pushes just in case they need to see it. So I got this little recorder here with a red button. I'm going to press record. Now that's recording my key presses. So I want to make a graph. I want to set it up. It's coming out of list 1 and list 2. So I want to make that a scatter plot. That's coming out of list number 1. And then list number 2. Everything else is the same. Exit. I will select and make sure that the second 2 are turned off and off. And then I will draw. So that's my original scatter plot. Now when I press stop, it has recorded my entire presentation up until that point. It didn't do the audio, it's just doing the information. Now what I tell students, or when I press play, I have to be very careful here that I start at the very beginning and I'm right at the first screen, because what it's going to do is it's going to press these buttons in this order, but I have to be in the same screen. If I'm in a screen other than this, if I was in screen 2 here, the first button it would push would be F1. So I want to make sure I start in the exact same spot at the very beginning. I press play. Now I'm not touching the screen at all. So now all I'm doing is explaining what the calculator is doing, and notice it's highlighting all the button pushes as it presses them, both on the emulator, and it highlights them in the video. So you're getting the exact same playback for this setup, so that students have it, you've got it. You can save this onto your YouTube channel or wherever you go and do your explanation. If you're doing a Google Classroom, or if you're doing a classroom in Word or Microsoft, you can upload those videos there as well. So all of this information is there for you. It's easy to use. It's a great environment. You can do most of the operations that you want to do in this screen with single button pushes. Just pressing one button, follow the screen like you would in a cell phone. So just a lot of power And the great thing is it's not very expensive if you're looking to save a couple of bucks. It's a great piece of technology. So again, it teaches your entire AP Stats curriculum from basically one screen, maybe two screens. If you want to do some probability, you can go into a different screen, but you could access probability distributions from here as well. So, any questions or comments?
No?
I wanted to add that we actually are, this software typically has a 90-day trial period, but we are offering it through the end of August for free for teachers or students. I'm going to put a link in the chat box so that that'll take you to all that information.
That's awesome.
I don't see any questions, Ish.
All right. Well, we are here. Let me pull up my screen here. We are here. Here's our information. If one of you wants to talk about the, Amy just talked a little bit about the emulator.
Yeah, so actually the link is in the bottom left corner of that PowerPoint. So it's there both places. So it's casioeducation.com/remote learning. And when you click on that link, you'll want to scroll down to the download emulator calculator software section and click on that learn more button. And that'll take you to the website that'll allow you to download actually multiple different types. So we have emulator software, which is just using for our scientific calculators and for all our graphing calculators as well. And then, follow us on social media. This webinar is being recorded, so it'll be up on our YouTube site, hopefully by sometime tomorrow. So if you wanted to go back
Yep.
And watch it again, as well as our webinars that we've had since like the middle of April that we've been doing, they will all fall under a webinar channel. So anything that's related to our graphing calculators and our scientific calculators. And then if you have any questions, anything that you see or anything that, pops up as you're, watching our videos or going through our websites, you can email us at calctraining@casio.com. And then follow us on social media. If you have any of those social media platforms, we post about all our other webinars that we are hosting on there as well.
Oh yeah, also, if you're looking for classroom material, pre-made stuff, there is material that is pre-made on the edu.casio.com site. Feel free to peruse that, look that over. You name it, we've got it. It's all out there. You just got to look for it, or email or get a hold of us through social media like Amy was talking about. But
yes,
whatever your needs are, I think we can meet them.
We can. Don't think. We can.
Oh yeah, we can.
Absolutely.
And then some.
We also have a bunch of other resources available on that remote learning
Same
page.
link, yeah.
Yeah, with that remote learning. So if you click on that, you'll find a bunch of other different things there too. So.
And in lots of different languages too.
All right. Well, thanks everyone for joining us. We appreciate you taking the time, and thank you, Ish, as always.
Thank you, Amy. Thank you, Karen.
Good night, everybody.
Good night.
Good night.